a lot has not changed from what you would say your traditional SATCOM antenna, but what has changed a lot more recently, I would say, are the applications. So think of it from an application standpoint, I would say there's a lot more that we've seen on the non-geostationary satellite or satellite networks front. So there's been a lot more development on LEO, MEO type full motion antennas, the smaller ones for communications. As you know, LEO antennas have been around for a while, full motion antennas, but to a large extent for Earth observation and applications like that. But we're seeing a lot more products being developed for full two-way communications, not only at KU band, but especially now at Ka band, and now we're even looking at higher bands. So yeah, I would say a lot more of the development that we've seen recently is on full motion antennas and the applications that go along with that, especially for two-way video, voice, data communications in general. So for multi-orbit communications, we're again moving away from the traditional geostationary orbiting satellites where you put the satellite up there, it stays for 15 years. You have an antenna and you point it there and, it just stays. Sometimes some level of tracking is needed. But now we're talking about GEO, MEO, LEO, and in some cases, handing off traffic between these orbits. So I would say what would be really useful would be antennas that are of lower profile. As you know, Kratos, we make parabolic antennas, which traditionally been large and even small antennas still to some extent. But these are typically used in gateways for trunking and so on. But the ones for LEO, MEO, besides the gateway antennas that we make, we do make roughly a 3.5 meter antennas. But to move to the next level, and again, this is not an area that we are playing in today, low profile or flat panel antennas. I think those are the technologies that are going to drive the success of multi-orbit antennas for two reasons. One, for the applications that are utilizing these antennas in flight connectivity, for example, maritime operations, which is not so limited in terms of needing low profile antennas. They have plenty of real estate. But when you're thinking about looking at GeoArc, looking at MEO, looking at LEO, antennas, especially electronically steerable antennas, will be really, really important for to be able to see multiple orbits, transfer of traffic, or I should say seamless transfer of traffic between those orbits. It's a lot easier when you're looking at a low profile flat panel type of antennas. I think those are critical for the advancements of some of those services. Well, I think the good thing is that we have several players there today. Good thing is good competition. And I would say also the fact that we have different way of approaching it, because we've had players in the market for 20 years or maybe even more. They've had their challenges, they've had their successes. So I think the more players in the market today gives us a different approach to the technology, different ways of implementing these services. And also another big thing is more competition means, hopefully better pricing. But I think better pricing is sort of relative, because where the cost points are for a lot of these systems, it would have to change drastically in the lower direction for it to be very attractive for commercial uses. So I think just having several players looking at the problem in different ways, I think eventually we'll get there, but I still think we're a ways off from there. As we go up in frequency, and we saw the emergence of Ka band 15 years ago. Time sure flies. So 15 years ago, when Ka band was just coming on board, from a commercial standpoint, we've had Ka band for a long time, as you know. But things were very expensive at the time because we didn't have as many players making Ka-band hardware. Even today, Ka-band LNBs are still very expensive. So just think of that as a data point and looking at where we need to be for Q and V band. We have today manufacturers that are making amplifiers, solid state amplifiers, as well as traveling wave tube amplifiers. Some are already in the market. So price is going to be critical. And coming up with products that can cover such wide band is a challenge. Because we're moving to Q and V band now because the K band spectrum is getting a little crowded. We have so many players, fixed geo as well as non-geo applications. So I think RF equipment from LNAs, amplifiers, converters, again, will have to get to a point where, first of all, they can meet the technical requirements, and to be at a price point where it's feasible enough for users to pay for these systems and to be able to make a profit, at least to get a decent return on investment over some short period of time. So yeah, we'll continue to see it emerge. Not a problem that has not been addressed before with lower frequencies. So I have no doubt in my mind that as an industry we'll get there. But these are just some of the challenges we have to face, pricing, as well as some of the technical challenges of going at such high frequency. And then, of course, you also have the issue of on the network side. I mean, the higher you go in frequency, the more link margin you need, which means you need, maybe bigger antennas, which means at such high frequencies, you need better tracking algorithms, some of the things that we're working on today. Likewise, you may need bigger amplifiers. Some of the things that the amplifier guys are working on today, which is not an easy problem to solve, especially when you're looking at traveling wave tubes to get those kinds of powers. So, evolving problem. Again, nothing that will not be solved over time. It's just a matter of taking the time to flesh it out. But I see this as a promising place to go. The higher frequencies, and even higher than QV band, will eventually come, because when you think of the amount of traffic or the amount of data that needs to be moved from one place to another today, and look at the projections they have 5 years out, will have to be there. So I think it's an issue from an RF standpoint or from a network standpoint that will be solved. So when I think of terrestrial interference, I would say maybe we're looking at the proliferation now of 5G, and the only overlap that I can think of with 5G is probably the lower end of the C-band spectrum that's sharing part of 5G. Yeah, so we'll have to deal with terrestrial interference just like we've dealt with it in the past. In fact, terrestrial microwave systems long ago interfered with C-band satellite communications. So similar problem. We'll just have to figure out where the interferences are and add filters accordingly. But I think to a lesser extent, though, C-band is being used less and less for satellite communications. Not because it's not good, because as you know, C-band is very resilient, especially to rain, and we have, very inexpensive components of C-band, because most of the traffic today, or the demand, really is at the higher frequency. So I think C-band will be less of a concern. Not sure if there is a lot more terrestrial interference at the higher frequency bands. I doubt it very much, but I think most people are probably focusing on 5G interference to C-band satellite operations or satellite communications, but I think it's less of an issue, at least in my mind.